Hi, so today I'm going to be sharing a new file for the motorcycle dynamic calculators, as I'll be moving from Excel to Google Sheets. This is to make it a bit more accessible for everyone. However, it is a little bit more tricky to get certain features to work, so it's not quite up to what I hope to have. So I will be updating it as we go forward. This one is only going to be for a hardtail frame. So in the future, I will be releasing a direct mounted suspension version and a rocker linkage suspension version as well. I'll try and keep them separate this time so it's a bit more simpler and organized. Now, after showing you the calculator on the PC here, I'm also going to show how you can take the measurements of the motorcycle yourself with the most minimum specialist tools, but perhaps a bit of help from a friend would be useful. We'll also show how you can take some of these final points using the PC. With that said then, let's get into the calculator. Okay, so when you open the motorcycle geometry calculator, the first page just has a few bits and bobs. This page is going to be a kind of manual and technical sheet where it's going to explain the background of everything that we're looking at. Now the main page you're going to be interacting with is the Hardtail geometry input sheet. Here we got a picture of the motorcycle. You want to put a picture of your own motorcycle there. And then we're going to start filling in our data. The data that we're looking at is going to be some physical measurements that we're going to take ourselves, so rear wheel, front wheel radius, and wheelbase. The front wheel and rear wheel radius we could calculate based on the rim size and tires, but because that radius is really going to fluctuate with pressure and temperature and the amount of weight that's on it, I'm just going to take a measurement myself. The wheelbase will take a measurement for now, but once we've built the calculator, we'll allow this to become a driven parameter. For our fork offset, that's going to be fixed. That's going to be the distance between the fork and the headstock. That's going to be built into the triple clamps. Fork length, we'll start with a base value, and then we're going to adjust that when we start including our fork travel. We have a rake angle. We're going to take that measurement to start with on the PC. Now, with the picture that we include here, we can use this transparent protractor that I've drawn up. But it's very rough and crude. I do recommend, as I mentioned here, check with a protractor or in CAD. You can put these pictures into 3D CAD and then sketch over it. Or I recommend also, I found this Chrome extension protractor. So you can actually just hover over your bike with this protractor here and take measurements. So that's actually quite a handy tool. Based off our rake angle, front wheel radius, and offset, we can then calculate our trail. Any equations required are going to be included here, as well as on the first page once these sheets are more complete. Headstock length, that's just for this visual reference. And then headstock angle to frame, I include that because if you are planning to fabricate a frame, this is one thing that you're probably going to be modifying and adjusting just to get the geometry that you want. And then that can be included into the calculations later on. As I said, fork travel is going to be one of our variable inputs. Probably not going to be measured manually by hand unless you're looking at sag or something like that. Weight distribution static. So here we're looking at the X position of the center of gravity. Basically, it's based on the weight on the rear, the weight on the front, both with no rider and with a rider. In industry, you're also going to include a pillion because bikes can be ridden either, well, with riders, definitely, but also sometimes with pillions. So they need to make sure it's going to be safe geometrically for the dynamics of the motorcycle. So of course we need to include the rider weight, but also if we are looking at dry weight of the motorcycle, when you're looking on online for information for the weight of your motorcycle, include gasoline, especially if your motorcycle is stored dry. You want to include fluid weight as well. Then we've got weight distribution, static arrays. So in this case, we've got, again, no rider and rider, but this time we want to introduce a tilt to the motorcycle. So we'll be lifting the front end. The more you lift the front end, the more you can eliminate discrepancies in measurements, things that would make your measurement, your current weight measurement be less accurate. The higher you raise that, the more you'll be eliminating those discrepancies. That said, the higher you raise the front wheel, the more difficult it's going to be to support it and keep it stable. So for our purposes, we don't really need to raise it that much. I'd say just 10 centimeters or something like that if you can. And then with that, we'll have our X and Y center of gravity, and this is all going to come into play later on. For those as well, I've included the equations here, but you can also refer to some of my other YouTube videos where I've got all of these broken down and defined. Then of course, moving on to the next sheet, we've got a geometry calculator sheet. So this is where we're actually calculating the triangles that make out the motorcycle, as well as the point positions of each node of the triangle. So going from X to Y position of the rear wheel to eventually the front wheel, because that's including the wheelbase. Ideally, this would be used to plot the motorcycle in a graph like these lines are shown here, which is what I had in Excel, but I've not been able to get to work in Google Sheets just yet. I'll keep trying to figure out how to get that done, and then I'll update these sheets. Moving on to the hardtail wheels, so we just plot the rear wheel and the front wheel based on the radiuses, and then for this one we've just offset it by the wheelbase, and then these are then brought into the geometry, well, the graph that should be representing the motorcycle. So once all that's done, I'll update this sheet again, but for now let's start looking at taking these measurements. Hello, today I'm going to be showing you how you can collect all your geometry data so you can start building your own calculators and analyzing your geometry as you make adjustments. And I'm going to be doing this with a most basic tool, so we don't need a workshop or anything, because I've spent all my money on the bike. The tools we'll be using: tape measure, some kind of tape that we can write on, and something to write with. We're not going to stop at the geometry, we're also going to calculate the center of gravity. So we'll need a set of scales, and for that, as I said, I spent all my money on the bike, so I'm just going to use my cheap bathroom scales, and I'm only going to need one set. So the whole point of having two sets of scales is so that you can measure the weight on the rear and the weight on the front at the same time. But realistically, we don't really need to do that. If we only have one set of scales, we can do one wheel at a time, as long as we make sure that the bike is still level, because that set of scales is going to raise the front wheel, so we need to raise the rear wheel equally. So I've folded up some cardboard to get roughly the same height. So once we've checked the weight on the front wheel, I'm going to swap it around and check the weight on the rear wheel. But of course, we're also going to include myself, the rider. So I will be stepping on the scales embarrassingly in just a moment. Okay, so we're going to start with wheelbase. I'm going to take some yellow tape here. I'm going to lay this down in front of each front and rear wheel. I'll try and keep this roughly in line as well, just so that it's easier to take a measurement later on. So I've also got my notepad, tape measure and pen. So let's mark out the first point. So we're going to want to take this measurement with the bike upright if we can. So I'm just going to pull it off the side stand and use this tape measure to roughly get both the front wheel radius, which is roughly 305, and also keep it there so I can mark it with a pen in a moment. As long as you're confident that your side stand is stable. As for the rear wheel radius, is 315. We've marked out the wheelbase, so let's check that measurement now. Okay, so checking our wheelbase, we can see, follow the longer mark, roughly 1400 millimeters. Okay, there's a couple more useful pieces of information to take. We'll start with the offset from the headstock axis to the fork stanchions. Just do this with a tape measure and a straight ruler or a straight edge, and you should get something like 30 millimeters. And then the next thing is going to be our swing arm pivot position. So we can take that in terms of Y fairly easily. So best to straighten the bike up here as well. We get around 425. So it's also going to be useful to know the length of the swing arm. But in this case, we have an end can in the way, so it's going to be a bit problematic to get a nice measurement here. But on the left side, we have nothing in the way. So I've already taken that measurement, and it's 590 millimeters for the street triple. Now the fourth part is going to be very important as well. This is going to be the suspension. So we're going to have our front forks and the rear shock. The problem we have here though is that we want to take a measurement of them fully extended. So unless you have it written down online somewhere to tell you that, you're going to have to take the measurements yourself. Best way to do this is going to be to have a friend to help you. You want to unload the front end, take a measurement from the bottom to the top, and then you can rest it down and then see how much it compresses. And then if you can fully compress the shock, fully compress the forks as well to get that condition as well. Same goes for the rear shock as well. Okay, so how I'm going to do this is I have the bathroom scales here, and I've folded up some cardboard to roughly the same height. I've jumped on this, it doesn't compress any more than the thickness of these scales. So what I'm going to do is I'm going to place this cardboard just in front of the rear wheel. So as I push the bike up onto these scales, it should be at the same height at the rear as it is at the front. Now, if you're in a situation like me where your scales are going to switch off by the time you get to take a look at them, I suggest setting up a camera, your phone to record the scales so you can get the value there. And just like this. Once you have it on the scales, you want to try and center and balance the bike so it doesn't feel like it's going to tipple either way. And then just say something to let the camera know right there. Then you'll have your sound, your voice as a cue for which measurement you actually want to take. And then we want to repeat that again with the scales on the rear. But to save time moving everything around, let's keep it how it is. Let's switch on the scales again. Let's push the bike up. And then let's try to balance ourselves on the bike. And then roughly there. And then we swap it around. Switch on the scales. And push the bike up. Until it feels steady around there. And of course, you can always use the front brake to help balance the bike. And of course, don't forget to check the weight of the rider. 105, that's embarrassing. So we also recommend that we try to get our XY position of the shock upper mount relative to the swing arm pivot. That's going to be a useful reference point to take that dimension from if you're able to access it. And then, of course, depending on your configuration, we may have a rocker linkage. So it'd be good to try to get these dimensions as well, so we can take the XY of this mount relative to the swing arm pivot as well. And then the whole rocker linkage assembly as well, including the dog bone or dog arm, whichever one you want to call it, because that is one part that we can actually easily modify the length of. Changing the length of the dog arm is a common thing in some racing. So why are we taking all these dimensions when we can easily find some of these online? Well, essentially it's because things are going to change on your motorcycle. One clear example, or easy example of that, is your wheelbase. That's going to change with your chain slack. As it slackens off, we need to adjust that chain. So obviously that means as we adjust the wheel back, our wheelbase is going to lengthen. So there's many things that's going to affect this. In addition to, as the suspension compresses, it's also going to flatten out the swing arm, increasing the length of the bike. As well, the compression and decompression of the front suspension is also going to have an effect. And all of this is also going to knock onto your rake angle and your trail. So we take the measurements as a baseline now, because this is how our bike is set up in this current state, so we can keep track of any changes as we go. So I wanted to make this video during the day. Unfortunately, I've had no time in the last couple of weeks to do anything with the motorbike, so I've had to only work on it at night time, which unfortunately leads to all the the background noise of the bugs. So I do apologize for that. If you have stuck through to the end of this video, I really do appreciate it. Thank you very much. I will be sharing the updated files soon, and I will announce when they are released. And yeah, thank you very much, and I'll see you on the next one.